Welcome to this lesson on network security in Kubernetes. Today, we'll explore how to encrypt cluster traffic using TLS, or Transport Layer Security. This is a critical component of securing communication between various Kubernetes components. Understanding TLS encryption is essential for maintaining the confidentiality and integrity of data as it moves through your cluster. Let's start with the basics. TLS, which stands for Transport Layer Security, is a cryptographic protocol that encrypts data in transit between cluster components. This ensures both confidentiality and authenticity of the communication. TLS protects communication between the API server, etc., Kubelets, and other critical components. It uses certificates and a public key infrastructure, or PKI, for mutual authentication. By implementing TLS, we prevent eavesdropping and man-in-the-middle attacks, which are common security threats in distributed systems. Now let's look at the key Kubernetes components that rely on TLS encryption. First, we have the API server, which is the central control plane component that serves the Kubernetes API over HTTPS. Second is etc., the distributed key-value store that requires encrypted communication with the API server to protect sensitive cluster state data. Third, the Kubelet, which is the node agent that communicates securely with the API server using client certificates. And finally, the controller manager, which runs controllers that authenticate to the API server using TLS certificates. Each of these components plays a vital role in the secure operation of your cluster. Kubernetes uses three main types of certificates for TLS encryption. The first is the Certificate Authority, or CA certificate. This is the root certificate that signs all other certificates in the cluster, establishing a chain of trust. Second, we have server certificates, which are used by components like the API server and etc. to prove their identity to clients. And third are client certificates, used by components like Kubelet and Scheduler to authenticate themselves to the API server. Understanding these certificate types is fundamental to managing cluster security. Let's examine how to configure TLS for the API server. The API server requires several certificate-related flags. The TLS cert file flag specifies the server certificate, while TLS private key file points to the corresponding private key. The client CA flag indicates the CA certificate used to verify client certificates. For communication with etc., we use EC-CAFL for the etc. CA certificate, EC-CERTFL for the client certificate, and EC-KEYFL for the client private key. These flags ensure secure, authenticated communication between the API server and both clients and etc. Moving on to etc. configuration. The etc. component has its own set of certificate flags. The cert file and key file flags specify the server certificate and private key, respectively. The trusted CA file flag points to the CA certificate for verifying clients. Setting client certauth to true enables client certificate authentication. For peer-to-peer communication between etc. nodes, we use peer cert file and peer key file. Properly configuring these settings ensures that your cluster's state data remains encrypted and secure. Now let's look at Kubelet TLS configuration. The Kubelet uses TLS cert file and TLS private key file for its server certificate and key. The client CA file specifies the CA certificate for verifying API server connections. Two important features are certificate rotation. Setting rotate certificates to true enables automatic rotation of client certificates, while rotate server certificates enables rotation of server certificates. This automation helps prevent certificate expiration issues and maintains continuous security. Finally, let's cover some essential TLS best practices. First, rotate certificates regularly by enabling automatic certificate rotation to prevent expiration and security vulnerabilities. Second, use strong key sizes, a minimum of 2048-bit RSA keys or 256-bit ECDSA keys. Third, monitor certificate expiry by setting up alerts before certificates expire to avoid unexpected downtime. And fourth, secure your private keys by storing them with restricted permissions, typically 600 in octal notation, and use secure storage solutions. Following these best practices will help maintain a robust and secure Kubernetes environment.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.